Having discussed the moment of inertia in the previous video, in this video we will talk about a concept which is connected to moment of inertia, radius of gyration. Let us take an example of a body. Let us say this is a body of irregular shape and mass m. Right? And let me just quickly go through once again what is moment of inertia. Let us say we have this body rotating around this axis, right? And this body would be comprised of n number of particles. What I do is I take the product of the mass of each particle, which I assume to be same, so m or m1, and take the distance of this particular particle from the axis of rotation. I'll call this r1, and I take r1 square. Then I take particle number 2 of mass m2, take its distance from the axis of rotation, r2 square, so on and so forth. And this sum will give me the moment of inertia of this body. In other words, I write I as sigma of mi ri square, I is equal to 1 to n. Right? This is what we discussed in the previous video. Right? Let's now move on to radius of gyration. Radius of gyration has a symbol k. Right? So we will use the symbol k for radius of gyration in this video. What is radius of gyration? Let me put it in words. It is the distance from the axis of rotation where, if we assume the total mass m of the body to be concentrated, then the moment of inertia I of this mass gives the total moment of inertia. Right? So let me repeat this. It is the distance from the axis of rotation where, if we assume the total mass m of the body to be concentrated, then the moment of inertia of this mass gives the total moment of inertia of the body. Too many words over here. Let me explain this. Right? So we have taken this particular body over here, and we have the moment of inertia I. Now, the radius of gyration of this body will be that distance from the axis of rotation. Let us say this distance will be denoted by k, where if I assume the total mass of the body to be concentrated, so this is the total mass of the body, capital M, because the total mass of the body is m, if I is concentrated, and if I find the moment of inertia of this, which will be mk square, right? The way we take over here mass and distance from the axis of rotation square, same way mass is total mass of the body, k is the distance from the axis of rotation, mk square will give me the total moment of inertia of the body I, which will be equal to sigma mi ri square, I from 1 to n. I hope with this you have got some idea about what moment of inertia, what radius of gyration of an object is. Right? To help you understand this further, what we'll do is we'll take actual values and calculate the moment of the radius of gyration of a body. So let us assume 3 mass body. So let us say this is the axis of rotation, and let us say we have mass 1. Right? Let us say this is the axis of rotation. This is mass 1. Right? At some distance, I'll take another mass right over here, and let us say mass number 3. And let us give these values. Let us say this is 1 kilogram. This is say 2 kilogram, and let us say this is 4 kilogram. Right? And let us say this distance is say 2 meters, 1 meter, and let us say 4 meter. Okay? So this is a 3 mass body, right? Instead of taking n particles, we're taking 3 particles, right, for ease of calculation. So let us first calculate the moment of inertia of this body I. Right? I know I is equal to sigma mi ri square, I is equal to 1 to n. So for this I body, I'll have to take mass. First I take mass of 4 kg, multiply by distance square, so 4 square plus 2 into 1 square plus 1 into 2 square. So that will give me 4 into 16 plus 2 plus this will be 4. So this will be 64 plus 6 is 70. So kg meter square. So the moment of inertia of this 3-mass system turns out to be 70 kg meter square. Now we will try to find out the radius of gyration of this body. So what we will do is we will assume that at some distance k, right, at some distance k, right, the total mass of the body is concentrated, right, and this total mass would be 4 plus 1 plus 2, 4, 5, 6, 7, 7, right? And the moment of inertia of this system would be mass is 7 into k square. And if the 7 k square turns out to be 70, then this k is the radius of gyration of this body. So let us do this calculation. K square is equal to 70 upon 7, right? This will give me 10, k square is 10, and k would be, in that case, if this is 10, this would be 3.3 something, some value, right? We don't want to get into the exact value of this, but square root of 10 would come something around that 3.3 meter, right? So the radius of gyration of this body is approximately 3.3 meter. Right? So this is how we calculate radius of gyration of a body, right? And this is closely connected to moment of inertia. A few final points on this. Let us look at the applications of this. Where do we use this and how is it useful? Right? It's mostly used in engineering. In structural engineering it is used, right? If you have a column to measure the stiffness of a column. So radius of gyration is of a column, if you know, then we know in which direction it will buckle. So it helps an engineer to design a column like this. Also, in the next topics that we're going to discuss, we'll be talking about the relationship between torque and, say, moment of inertia. And when we do this, or when we try to find this relationship, we will be using radius of gyration. Similarly, the relationship between angular momentum and moment of inertia, and also torque and angular momentum. Torque and angular momentum. So when we discuss all these topics and the interrelationship between these, we will be using radius of gyration to find out a relationship between these terms. Right? In the next video, we will discuss the relationship between torque and moment of inertia and see how radius of gyration plays a role in that. Thank you.